Hello and welcome to Let's Get Tanked, an introduction to tank safety. My name is Sonntag, this is Ryne Gambill, and joining us soon will be Colby Wilmeth. So why is tank safety important? Well, oftentimes tanks give a false sense of security, and they're often neglected in process safety considerations. However, review of some statistics will yield proof that they are often not inherently safe. For example, from 1992 to 2005, there are over 431 confined space incidents, resulting in 530 deaths. And in 2010 alone, there was 63 deaths and 28 hospitalizations. So a big part of this is a high rate of exposure. For those involved in the chemical process industry, such as engineers and operations, it's obvious how they would be exposed to tanks. But we also took into consideration those who are not in industrial settings. And to talk about some of these hazards, I'll pass it over to Ryan.
To show the importance of safety, we shot many scenarios, such as entry and cleaning, energizing motors, how to de-energize yourself around the motor, filling tanks, chemical hazards such as PPE, fueling hazards such as PPE and how to handle proper fueling techniques, and equipment sizing. To demonstrate these scenarios, here are Colby and Tyler.
Hello and welcome to another exciting safety video. My name is Sonntag. I'm joined by my safety enthusiast, Colby Wilmeth, and behind the camera we have Ryne Gambill. Today we'd like to discuss tank safety a little bit. Now, it's kind of easy to think that not a lot oxygen depletion. We have energizing electrical equipment, which is an electrical shock hazard. We have flammability hazards and temperature hazards, as well as chemical exposure hazards. Now, to cover this, we'd like to start with this tank right here, which is a 1,000-gallon water tank. We'd like to start by analyzing this associated water tank. Now, typical breathing rates are between 7 and 8 liters a minute of air for a full-grown adult. However, if you're on an industrial setting or farm setting, as we are here, it can increase up to even 15 or 16 liters per minute. We did several calculations to keep the oxygen in a tank of this size and of other sizes and at multiple breathing rates. Before we cover that, though, it's important to understand how oxygen can affect a human. Normal air is approximately 21%, but at 17%, mental abilities start to become impaired. At 14%, physical labor can be extremely exhausting on a human. At 10%, unconsciousness is possible and nausea will probably be experienced, and below 6%, humans will not survive.
Here we have our 1,000-gallon tank that we're preparing to do some cleaning on. That we're going to have hazards of space, close space, whenever we get inside, and that means that the amount of oxygen that we're consuming is going to be an issue. In order to work this out, we have an approximate amount of time that we can do the process that needs to be done inside the tank until it becomes dangerous. At 10 liters per minute, the average a working person to be inside and breathing, we have about 3.2 hours of actual working time. But on this setting, when it's hotter inside the tank, we're going to have about 2 hours to work. To clean this tank, we're also going to make sure that we can set a time for a limited amount of time that he can be in there safely in working range. So at this point, we're going to start our clocks. You're going to go ahead and start cleaning. Approximately 3 hours later, we're done and he can come out.
Plot twist!
And now it's been 3 hours later. There's no sign. What could possibly be wrong? He's not coming out. What happened? Temperature. It's 85 degrees today, but he's in a black tank. That means that inside the temperature can be over 100 degrees, which means that the hazards increase. That heat stress, heat exhaustion can cause the oxygen to be even more intense, and that we can actually cut down the time working inside this environment.
Now that our tank is clean with only minimal fatalities, I'd like to take us to the back of the room. Operating tanks like this often take gasoline-powered engines, and to operate these safely, Colby is going to demonstrate the checks and procedures you go through, and some of the things to watch for while operating it, starting it, and during its operation.
On sure you have plenty of gas to run the motor. And that it's completely sealed so the fumes of the gasoline don't get out and mess up from the hot muffler that will be running during the process of loading from the tank. So on these, they're pull start engines. In order to pull start them, there's a number of hazards in order to crank this. This chain, you have to yank. That is a pinch point hazard right here. During its operations, like I said, the muffler is extremely hot. These are some of the main hazards associated with a pump of this.
Thank you, Colby. Right now is we are outside, and operating an engine like this has pretty bad emissions. And so if you operate it in a closed environment like this, you have pretty high probability of noxious fumes building up. What do you use this pump for, Colby?
This pump is mainly used to push the water and any chemicals that you're applying in your application in the field to the implement that you're applying it with. And in this instance, the other application or other instance is when you're applying chemicals. This is also a fume that can be built up also like from the motor.
So what kind of PPE do you need to wear when you're trying to fill a hopper like this?
The PPE that is most common used is a splash pad for chemicals that may have splashed up while you're liquid, and gloves here that are chemical to whatever chemical that you are using. In this process, we have this funnel right here to help us transfer the liquid over easier instead of taking it and putting it in the big opening in the top. Now we're going to try to transfer it.
As you can see, Colby is fully protected. Obviously, the arms are exposed, but this is not an extremely hazardous chemical. It's just great to keep it off the hands and, of course, out of the eyes. Both wearing boots are water resistant or waterproof, and steel toe, which is also good to have on your person for working in these kinds of environments.
What we have here is a 5,000 gallon tank that we store diesel for the farm use. As you can see, here's the filler gauge right here, and this means it's halfway full. This is where the line is. And it is also a good thing for maintenance on these, to keep everything nice and clean, keep these well clean so you can tell exactly where you're at. And as we saw on the previous, the equipment for the spraying, we need to have that as clean as possible to keep it from having contamination and any type of fumes, and make sure that we have no leaks, and to keep everything just well maintained for proper usage. And it's also good for safety. As we are here ready to use this diesel from the nurse tank, we have to make sure that everything is situated where we need to use it. We have an electric pump that is not energized by a battery, an external battery. It can be a battery off of a tractor or a vehicle. And we have these lines right here. And as you can tell, here is the black positive ground, and here is the negative to energize it. And as you can tell, there's an insulator missing, so we have to be very careful on electric discharge from static electricity. So we go over here, ground ourselves out on the metal, make sure that everything is pretty much as static free as we can get it. When we come back, we will connect the ground first, positive pole, and then the negative pole to energize the battery. Then we'll come over here, make sure that this is off, then use this pump right here, put it into our tank, open the valve, make sure the valve is completely open, make sure our main valve is completely open so we have clean flow through, and then we can turn on our pump so we're not overpressuring anything and making it more turbulent or more fumes than normal. Then afterwards, we shut everything off, we turn the motor off first, we shut this off next, then we disconnect the batteries, then we place it back into here, hopefully maintaining all of any leaking diesel into the pipe so we don't have any industrial waste like we have here, and we have it built up onto rocks to make sure everything stays in this area. Now that we have our proper PPE on, we're going to...
What Colby's trying to say is this tank is pretty clean, which is actually really good for we're trying to fill it and transfer the chemicals over to our sprayer over here. And to do this, we have an assortment of PPE. I'm wearing an entire chem suit, as well as one rubber chem glove and one glove that's leather to help against pinch points and things like that. So, Colby, would you like to start showing us how to connect this to the sprayer?
We have a water still here, and then we have these to lock in the valve. This cap here is to keep it from getting dirt inside the valve. Then we attach it and make sure it is snug and both sides are tied in. Then we turn it on, and this one on. Then we go back and start up our motor, remembering the pinch points in the exhaust, and pump it into the tank.
A couple other points that Colby was talking about here. These two latches that buckle down are really great for this. For that, you use the leather glove on my left hand. Also, you can see that the truck from spraying is pretty covered in the over. This is good. This is a good time to have your rubberized chemical protective glove on. And this is actually very powderized and it blows away with the wind, which is a good time to wear a respirator like Colby has on.
It's also a good time after you're done to clean up, as we are doing on the tractor right now. Another everyday common scene that everybody can relate to is filling up your vehicle at a pump. This is a pumping station. First things first, what we're going to do is we're going to de-energize the engine, because that cuts down on ignition sources. Whenever you turn this off, you get out of the car, you have to worry about static friction from the seat, from anything else that you're touching. Make sure that you ground yourself before you go and handle the fueling equipment, the nozzle, the pump. Make sure that you ground yourself out on there. So as we're getting out, you want to make sure you ground yourself out. Make sure there's no static electricity as best as you can. I know in the winter, you have a lot of times where it's cold and you want to get back in, but during fueling, you don't want to get back in and create more static electricity. It's really easy to forget to ground yourself out and have it ignite fumes that are already in the air. So from here, we go back. Another thing to make sure, it's not really a safety, it is a safety for the vehicle, but whenever you have your engine running and you open your gas tank, it actually has a vent in it that will actually sensor that, and it will pull an alarm on your vehicle to make sure that you turn off your vehicle. So here, you open that up, you make sure everything is good here, and there's nothing blocking it. You come over here, from the hose, you want to make sure that it's all clean, because that will mess up your engine. Make sure there's no residual water inside the tank. Well, there you go, that's left over. So after this, we come over here, make sure it's all the way centered up, so you have the vents on the sides giving the amount of the fueling tank while you're putting more fuel in. And in this process, you have to make sure not to answer phone calls or smoke a cigarette, because the fumes coming from the tank can actually be ignited in the process. So after we are done filling up, we have this nozzle right here, which is actually an older nozzle. The newer nozzles have a vapor recovery funnel on it that actually helps keep the fumes down and inside the tank. And I would suggest on those, letting it shut off and have some time to actually help those fumes go back in the tank before you pull it out. But after you're done, make sure that you have all of it drained out so you don't have any residual fuel inside the nozzle, and then replace your cap. Keep as many fumes as you can possibly in, and so you have all the air blowing it away, and you have an open ventilation system basically to keep all the fumes away. Now that we still have our nozzle out and we just completed our Whirlwind Tour Vespa race of South Plains, and we were the only winners because we're the only racers, but that's neither here nor there. I'm going to turn it over to Tyler to help finish up our refueling of our external tanks.
So to keep our Vespa running fast and furious, we keep this 5-gallon tank with us at all times. Now, you should never fill these small plastic containers inside the bed of your truck or inside the trunk of your vehicle, or if it's a hatchback in the compartment back there. Now, the reason is the vapors from the gasoline can build up if it's a smaller vehicle, and that obviously provides inhalation hazards as well as explosion hazards. And also static electricity from bed liners or other things can interact with the plastic and cause a spark and blow you up. So you always want to ground your tank on the ground. Most of these small tanks have a vent in the back, which you should always keep open to relieve any pressure that builds up, especially in these hotter temperatures. It'll build up a lot of pressure, so when you actually end up undoing the cap on the front, it'll spray out gasoline or large amounts of vapors if you haven't depressurized it with the vent at the back. So Colby, if you'd just like to insert it, it would be the normal filling process. Most of them have these funnels to help you fill any of your Vespas or scooters or
Extracurricular activities.
yeah. So other than removing the nozzle, making sure it's drained, and depressurizing the tank, everything else would be extremely similar. Here we have yet another type of energizing system and motor and pump setup. So here all the electrics are contained, and there's only a switch to turn on the motor. But the difference with the motor and the pump driving system is it's actually belt driven here. And this belt is an extremely dangerous pinch point, and if your clothes get too close to it, it can suck in your pants and rip them off, or worse, it can take your knee through it and blow it up, or there's a whole bunch of bad things that can happen. And this is actually a pretty large pump, and Colby's going to discuss a little bit about pump size and overpressuring vessels and things like that.
So the biggest issue with safety on as far as overpressurizing vessels is make sure that you have the proper equipment for the job. Don't oversize anything. Don't undersize it just because it's cheaper. That's one of the big issues. With this, you can fill a large vessel or medium-sized vessel, 1,000 gallons or 2,000 gallons in 20 to 30 minutes. And I've had several moments and experiences where that overpressurizing and the large volume has either broken seals or hasn't had enough of the ventilation and it's popped off the ventilation to the tank. So with that being said, we're going to try to oversimplify and over-exaggerate this problem. And I'm rather thirsty, so I'm going to try to fill up this nice lovely cup with this extremely oversized pump, and in the process get everything really wet. First things first, safety, right? Safety. Even though we're being inherently safe in our practices, the inherently safe situation is going to cause this issue. So to make sure everything's good, there's no issues with the electrical here. Here's the on and off switch. We come over here, turn this valve on, and then we crank it up. And that's how you oversize the equipment to get the process done.
As we just saw, there's a large variety of hazards associated with tanks and confined space entry. We'd like to recap these hazards, and most of them include suffocation, burns and electric shock, fire and explosion hazards, pinch hazards, as we saw with motors and clamps and such, and chemical exposure, as we saw with the dirty equipment.
Our preventative measures to mitigate these hazards are making sure that you have the proper PPE for the job at hand, gloves, respirators, especially when you're dealing with chemicals. The chemical suits are for whenever you're doing large volumes and a splash hazard, and the appropriate shoes, specifically in the industry where you have to have steel-toed shoes, you can drop hoses, they get rather heavy. The safety work practices are making sure the electrical equipment is properly maintained, all of the sleeves and valves and covers are working properly, and to double check that everything is clean and nothing inside the nozzle like we showed in filling of the vehicle. And just the general common sense of not oversizing, not undersizing your equipment, and getting the right stuff for the right job.
So in conclusion, tanks can pose risks, but these risks can be easily mitigated by proper measures. And we hope that you implement all these measures and safe work practices into your methodology, process design, and everyday life.
This is the Let's Get Tanked video. Thank you very much.
Finally, let's go get tanked.
Hell yeah.